Algebra 1, Concept 1180A, Graphing and Transforming Lines. Slope-intercept form of a line. We've been talking about this, so hopefully you know this by now. Y equals mx plus b, where m represents the slope and b represents the y-intercept, or where the graph crosses the y-axis. So let's talk about graphing these. In the first example, you can see y equals 1/3 x minus 2. The slope is 1/3. It's written in a fraction. So we talked about rise over run. And then the y-intercept, or the b value, is -2. When you go to graph these, you always want to start with the y-intercept. So I'm going to start at the origin and go down to -2 on the graph and plot a point. From that point, do not go back to the origin. Stay at -2. From that point, I'm going to go up 1 and to the right 3. You can repeat this as many times as you'd like. Up 1, right 3. What happens if you run out of space on the graph? Well, from the y-intercept, so -2, I could do the opposite of up 1, right 2. I could go down 1, up 3, up 1, right 3. I could do the opposite of that by going down 1 and left 3, down 1 and left 3. Notice that the line that I'm going to create is linear. It's all in a straight line. Okay, these are linear equations because the line that we're creating is straight. Let's look at the next example. Y equals x. When there's no number or coefficient in front of the variable, you can always add a 1. And if there's no y-intercept or b value, you can always add a 0. I like to do that. It just helps me know where to start. So I'm starting at the origin. I'm going to plot a point there. And it's not in fraction form. So I can put my slope as 1/1. You can always add a 1 to the denominator. So from there, my slope's going to tell me to go up 1, right 1, up 1, right 1. I can repeat that process several times. I can also do the opposite of up 1, right 1. I can go down 1 and left 1, creating a straight line, or again, a linear line. The next one, y equals -2x plus 3. Identify your slope and your y-intercept. Your starting point is your y-intercept. In this equation, your y-intercept is 3. So from the origin, or 0, 0, go up 3 places and plot the point on the y-intercept 3. From that point, you're going to want to go down 2 and right 1. Again, if you don't have a fraction, create one by putting the denominator 1. Down 2, right 1. Down 2, right 1. Again, if you can't keep going down 2 and right 1, you can always go up 2 and left 1. Connect those points and create the graph of the equation y equals -2x plus 3. What if we have these special situations? You have to remember Hoy in VUX. You have the equation y equals 3. Y is by itself, so I have to remember the acronym Hoy. Hoy, horizontal, slope of 0, y equals. So from the origin, I'm going to go up to 3 on the y-axis, and I'm going to plot several points across in a horizontal line where y equals 3. I can then connect those points and create the graph of the line y equals 3. The next one says graph y equals 2. X equals 2. So remembering the acronym VUX, this is going to be a vertical line, or one that goes up and down. The slope is going to be undefined, and x equals 2. From the origin, on the x-axis, I'm going to go to the right 2 and plot a point there. I can plot a point anywhere on the vertical line where x would equal 2, so I can plot several points and then connect those points to create that vertical line that represents the equation x equals 2. This next one, we're going to have to rewrite it into slope-intercept form, and then we can identify the slope and the y-intercept and graph it. In this first equation, 2x plus 4y equals 12. We need to get y by itself by getting the 2x to the other side. So I need to subtract 2x from each side. Remembering we're not combining 12 and 2x because they are not like terms. I'm left with y equals negative 2x plus 12. The inverse of multiplication is division, so I'm going to divide each term by 4 to get y by itself. Simplifies to y equals negative 1/2 x plus 3. My y-intercept is 3 and my slope is negative 1/2. Starting with my y-intercept, I'm going to go up 3 from the origin and plot a point. From there, my slope tells me to go down 1 and right 2. Do that multiple times to plot some points. Again, you can do the opposite of down 1, right 2. You can go up 1 and left 2. Connect the points, and you'll have the graph of the equation y equals negative 1/2 x plus 3. Graph negative 3x plus 5y equals 15. Let's rewrite that. We need to get y by itself, so we'll add 3x to both sides. When I do that, I get 5y equals 3x plus 15. To get y by itself, divide each term by 5. Y equals 3/5 x plus 3. Again, the slope is 3/5 and the y-intercept is 3, so we need to start at our y-intercept. From the origin, go up 3 and plot a point. Our slope tells us to go up 3 and right 5. Remember, once you plot the y-intercept, you're going to use your slope from that point. Do not go back to the origin. Okay, so I'm at the ordered pair, 0, 3. From there, I'm going to go up 3 and right 5. I could also go down 3 and left 5. I've created 3 points on the graph, and I can connect those points to graph the equation y equals 3/5 x plus 3. Try this one on your own. Pause the video. When you're done, check your work. All right, let's try to get this one into slope-intercept form. We need to move the negative 3x to the other side by adding 3x to the other side. That leaves me with 5y plus 10 equals 3x. We want to get the 10 to the other side. Remember, our goal is to get y by itself, so we'll subtract 10 from both sides, in which we get 5y equals 3x minus 10. Last thing to do is to divide each thing by 5. That's going to simplify to y equals 3/5 x minus 2. Starting at the origin, I need to go to the y-intercept negative 2. So I'm going to go down 2 places and plot a point. From there, from negative 2, I'm going to go up 3 and right 5. I know that if I go up 3 and right 5, I'm going to fall off the graph. So now I'm going to go down 3 and left 5, creating a point that will be linear when I connect the points and graph that equation.